Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me, and make sure that you check out the full playlists as well. I've got a playlist that's dedicated to LXD. I've also got one for open source in general, and I've also got some other playlists on my channel that surround topics like Amazon Web Services and PowerShell, and I'll be adding a whole bunch more content. Also, if you go to the community tab on my channel, you can take part in some quiz questions that you can use to help improve your learning about various open source and Linux related topics. So what we're going to be focusing on in this particular video is yet another feature of the LXD engine that allows us to manage the containers and virtual machines that we're creating on our LXD servers. This feature is known as projects, and projects allow you to isolate certain types of resources within your LXD server. So up until this point, we've mostly been working with just a single project known as the default project. In fact, I have a diagram right over here that kind of shows the basic structure of what projects look like. So when you initialize a LXD server, you start out with a project known as a default project. And again, don't get projects confused with profiles because they are two separate concepts. The project is more logical separation of resources, whereas profiles determine how your virtual machines are actually going to be configured, like how many CPUs they'll have, how much memory they'll have, any devices that'll be attached to the virtual machines. That's part of your profile, but the project allows us to manage the virtual machines and containers themselves, as well as images, as well as profiles, and storage volumes as well. Also, there's the ability to segment off different networks. So if you want to create a dedicated bridge network, for example, for one of your projects, you can actually do that to isolate virtual machines and containers at the network layer, in addition to the management layer inside of the LXD daemon. So by default, you have this project here called default. And if you don't specify any projects in your usage of the LXC CLI tool, then you're just going to continue working in that default project and you'll be none the wiser. If you start working in a multi-user environment, or even if you just individually need logical separation of the different resources inside of your LXD servers, then you can actually create your own custom projects. Now, remember that virtual machines and containers belong to a project. So when you're creating virtual machines by default, they're just going to belong to this default project here. You never really encounter the default project unless, again, you're specifically managing projects on your LXD server, but they do belong to that default project. If you create a secondary project with a custom name like Project 01 or something based on your name or whatever kind of naming convention you want to come up with, then you can elect to override the default project when you create a virtual machine or container, and that resource will then belong to that other project. Very similar to how you use remotes in LXD to remotely manage different LXD servers. We're kind of switching contexts between different servers. We can do the same thing, but at the individual server level or at a cluster level by switching contexts between different projects. So that's something you'll just want to keep in mind, is that when you go into a specific host or cluster, you'll want to kind of step down just one layer down into the project layer before you actually start to manage some of the resources that can belong to projects. Now, one of the interesting things about how projects work is that when you create a custom named project here, it can actually inherit the resources from the default project over here. So there's certain features that you can toggle inheritance either on or off. And so if we wanted to share images between the different projects, then we could simply allow our custom project here to inherit the images from the default project. Same thing with networks. If we just want to use the same virtual network, the bridge network across multiple projects, then we can choose to just inherit the bridge network from the default project in our own custom projects. And same thing goes for profiles and storage volumes. If we just want to use the predefined profiles and storage volumes that are in the default project here, we can choose to just inherit those in our custom project. However, if you want to disable the inheritance chain between the default project and your named custom project, then you can choose to enable those features in the custom project within the project's configuration section that we'll take a look at in just a few moments here. And that will allow you to kind of separate that inheritance chain, and then any profiles that you create in your custom project will be exclusively in that custom project, and the custom project will not have visibility into the profiles that exist in the default project as well. Same thing goes for images here. If we enable the images feature on our custom project, then we're breaking the inheritance chain between the default project and our custom project, and any images that we pre-cache into our custom project will exclusively be visible to that custom project and not inside of the default project here. But you can actually copy things like profiles in between projects if you're an administrative user, because you can actually copy them in between different projects. So if you had a predefined profile in the default project, but you enabled the profiles feature, effectively breaking that inheritance chain, then you could actually go ahead and just copy one of those profiles from the default project over into your custom project, even though the inheritance chain is broken. You're basically making a replica of it instead of linking to the original source. So that's really what projects are intended to do. There are some other features that you can enable on projects as well. So if we wanted to, we could actually create a remote user with a certificate to authenticate to the LXD server, perhaps from a remote workstation, and we could actually limit that user to only having visibility over a specific project or multiple projects. So if we had maybe 10 different projects on our system, but you individually are only supposed to have access to 2 of those projects, then we can actually restrict those projects and only give certain users permission to those 2 projects, and then administrators will have access to all of the projects across the entire LXD server. So it's kind of an access control tool that you can use as well. And there's also some security related features in here. If we go over to the LXD documentation and look at the project configuration here, this is kind of the reference material as far as the different features that you can enable or disable on a per project level. Again, you see things like networks, images, profiles, storage volume, storage buckets, DNS zones for networks, that kind of thing. But we also have the ability to set individual project limits as well. And then there's some security features that we'll touch on in just a moment. But as far as limits go, we can actually create limits on the entire project so that only a certain number of virtual CPUs can be used within that project. Maybe you've got a CPU that has 20 cores or something like that, but you want to restrict a project to only having access to maybe 2 or 4 of those cores. You can set those limits so that the users of that project can spin up virtual machines up to that virtual machine CPU limit. And same thing for things like memory. If you want to say allocate maybe 4 gigabytes of memory to a certain project, and then maybe 8 gigabytes to a different project, and then maybe 20 gigabytes to a third project, you can kind of divvy up your system resources and allocate them to these separate projects. And then the users that have access to those projects will be limited by those quotas that you set on each of the projects. And then down here, there are some security related features as well. So if you are concerned that users within a project might spin up some potentially sensitive workloads, then you can actually restrict some of the capabilities that those users have on those containers and virtual machines. For example, if you don't want to allow the deploying of privileged containers, you can do that right over here. If you want to set disk restrictions here, you can do that as well. If you want to prevent the use of GPUs on the system, you can do that. If you want to restrict your NIC devices, you can do that here as well. So there's a whole bunch of kind of security related features here that allow us to control the scope of what can actually be deployed inside of a project. But we're just going to start with some of the basics for now. We'll look at how these project features work from the inheritance perspective from the default profile, and we'll also take a look at these project limits here as well that allow us to limit access to resources like CPUs and memory right down here. All right, so let's go ahead and jump into a terminal. So let me fire up a new terminal right here. And I've already got a bare metal host that is running Ubuntu Linux server, and I've already got LXD installed on there. So I'm just going to go ahead and SSH into that host. It's just called Pangea right here. So once I'm SSH'd into Pangea, we can go ahead and just do LXC version. I'm currently running the latest release of LXD, which is 5.15. If we do snap info on the LXD package here, you can see 5.15 is the latest release, and I'm currently tracking the latest release. So as soon as a newer version comes out on the latest channel, I'll get upgraded to that by doing a snap refresh. So what we're going to do is take a look at kind of the default configuration of projects. So if we run LXC here, you can see that there is a project subcommand here, a subcontext. So if we run LXC project, we can manage projects very similar to other resources like virtual machines, profiles, images, that kind of thing. So we can create new projects. We can delete projects that we've created on the system. Also, we can list our projects so we can actually see the default project configured. We can show project options. We can also edit the configurations of our projects, or if we just want to set certain configuration keys inline on our bash shell, instead of using an interactive editor, we can use the set command, or if we want to remove a setting from the configuration, like if we want to remove a CPU limit or remove a memory limit or something like that, we can unset certain options by using the unset command. Also, with the LXC remotes, we've previously discussed that in a separate video. We saw how we could do the LXC remote switch command to change the default remote that we are currently working with. And so we can kind of do the same thing with projects. So we have the switch command down here that allows us to switch the current project that we are operating on. But a lot of the LXC CLI commands actually have a -- project parameter. So as you can see right down here under global flags, there's a -- project parameter that's available pretty much on every subcommand in LXC that allows you to override whatever default project you're currently operating on with the LXC CLI tool. So if you just need to run a one-off command against a particular project, you can just override it temporarily with -- project. But when you use the switch command, that's going to set the default project for any commands that don't use the -- project argument. All right, so let's go ahead and list our projects for starters here. So I'll do LXC project list. And because I'm running on the local daemon here, I'm running LXC against the local system. I have administrative access. I don't have a trust set up with any remotes at this point in time. So I'm going to be able to see all of the projects on the system as an unrestricted administrator. So here's our default project. We have all of these features enabled because it is the default project: images, profiles, volumes, buckets, networks, DNS zones for networks, and we can actually see that this project is referenced by 5 different resources. So if we want to see what those resources are, we could do LXC project show default here. And under this YAML used by key right down here, this is an array of values that contain the resources that are linked to the default project. Now, what would happen if we tried to delete the default project? So if we do LXC project delete, we just specify the name of the project that we want to try to delete, and it's not going to allow us to delete the default project because that would break a whole bunch of things, and we can't delete projects unless they are unlinked from every single resource that's linked to them either, as you'll see when you create a custom project. So even if we did have the ability to delete the default project, we wouldn't be able to because there are images, profiles, networks that are currently linked to this particular project. So what we'll do is create our first custom project. So I'll just do LXC project create, and then all we need to do is specify a name for the project. There's not really a whole lot of configuration that we have to do from the get-go because we can typically change that stuff a little bit later on. But what we'll do is say LXC project create, and I'll just call this Trevor. All right, so now if we do LXC project list, you can see that we've got default, which is the current default project, and we've got Trevor down here. So let's say that we wanted to change into the Trevor project. Well, we could do LXC project switch, and then specify the project we want to switch into. So now we've changed the default project that we're currently working on to Trevor. And if we list, you can see that the current project that we're operating on is Trevor, unless we override that command. So now let's go ahead and just download an image for a virtual machine. If we do LXC image list, you can see that we don't currently have any images pre-cached into this specific project. And if we do LXC image list -- project, again, that's a global flag, and we specify default right here, you can see that we actually do have several different images that have been pre-cached into the default project, but those are not visible to my Trevor project because we have disabled that feature on the project. So let's take a look at the configuration of the project before we actually pre-cache an image. If we do LXC project and then show Trevor, you can see that the images feature is true, which means it's been enabled on the Trevor subproject on my LXD server. And so if it's set to true, if we've enabled that feature, that means that the inheritance chain back to the default project is actually broken, and the Trevor project here is not going to inherit the images from the default project. Now, what we could do is actually change that by doing an LXC project set, and then we'll change our project and set a key and value. So we'll do set Trevor, and then we'll say features.images, and we'll set that to false instead of true. So now we've relinked the Trevor project back to the default project with that inheritance chain. So now if I do an LXC image list, you can now see that the images that were in the default project are now visible to the Trevor project, just in the same way that they are available to the default project itself. So that's how you can enable certain features or disable certain features, and either enable inheritance or disable inheritance for each of these features. All right, so let's go ahead and re-enable the images feature here. And if we do a list, we can see that we don't have any images because once again, we broke that inheritance chain back to the default project. So what we'll do is say LXC image copy, and I'll go out to the default Ubuntu remote. I'll grab the Lunar alias, and we'll just copy that to our local system. And because we are currently operating on the Trevor project, we don't have to worry about specifying -- project, but once again, you could override the project that this command is going to operate on by using the -- project global flag, just temporarily. So we'll let this pre-cache this image, and then we can go ahead and create virtual machines from this image inside of the Trevor project. And what we'll see when we create the virtual machines is that the virtual machines, again, are child resources of the project itself. So when we create a virtual machine based on an image in this same project here, that virtual machine is going to belong to our custom project. It's not going to belong to the default project over here. So anytime that we do an LXC list command to get a list of the virtual machines, we have to make sure that we're thinking about, well, which project am I operating on? Have I set a custom project as my current project, or am I just operating on the default project? All right, so now we'll do an LXC image list, and you can see we've got our Ubuntu Lunar Lobster image right here, 2304. Of course, that is a container image. So let me go ahead and copy the VM image instead. I'll give that a moment to download here really quick, and I'll come right back. All right, so now we've got this image copied onto our project. So if we do LXC image list, we can see that we've got a VM image and we've got a container image. Awesome. So let's go ahead and launch a virtual machine. So as we've seen before, we'll do LXC launch -- We'll specify our image, which is going to be Ubuntu :lunar, and I'll just call this U01 for now. And it says no root device could be found. So this is actually an issue with the profiles. Remember that we have the ability to set custom profiles inside of our project that are completely separate than the default profile in the default project. And if we take a look at the profile right here, let's do LXC profile show default, you'll see that under devices right here, we don't have any network interface, and we also don't have any root file system configured for this particular profile. So one thing that we could do to resolve this would actually be to enable inheritance for the profiles feature so that we don't have profiles unique to this project, just like we did for images. But the other option that we have is to just copy the default profile from the default project and actually copy it to a custom name inside of this Trevor project. So what we can do is say LXC profile show. And this time we're going to show from the default project, but we're going to display the default profile from the default project. And so what we could do is just grab the Ethernet interface and the root file system, the block device right here, and copy that. And then we could just paste that into our default profile for our Trevor project. So let's do LXC profile edit default, and this will be in our Trevor project, of course. And now if we go down to devices, we can just paste in that configuration, and now we'll have a replica of the default profile that's in the default project. We're just basically copying some of the settings from that other project into the custom project and profile here. So now if we try to launch our virtual machine again, it should have a root file system configured, a block device, for it to copy the operating system image to, and we should be able to launch a virtual machine successfully. And just to show you really quick, if we do LXC project show, actually we're going to do, project show Trevor, you can see that profiles are enabled. And so if the profiles feature is enabled for our custom project Trevor, then that means that we don't have inheritance from the default project's profiles. All right, so now we've got a virtual machine. If we do LXC list, you can see we've got the VM called U01. It's up and running. But if we do an LXC list on the default project on our LXD server, there aren't any virtual machines there. And again, that's because a virtual machine or a container are going to be child resources of the project that they were created inside of. All right, so that's how we can launch virtual machines. Let's talk about setting limits. So we've already looked at the inheritance of certain features like profiles and images, and that same concept is going to apply to other things like networks and storage volumes and storage buckets to do file sharing. So just be aware of that. Make sure that you understand the inheritance between those features and the default project on your LXD server. But now we're going to talk about setting these limits, like limits.cpu and limits.memory. So again, if we have a 6-core system, which I think my system here is a 6-core server, go back to Pangea. I think it's an i5-8400. Yeah, I think it's Intel Coffee Lake architecture. So it's, a number of years old. It's certainly not a new system here. It does have 6 CPU cores, 0 through 5. But let's say that we wanted to limit the Trevor project to only having access to 2 of those CPU cores. And we've got 32 gigs of RAM here. So let's say that we wanted to limit virtual machines in the Trevor project to having a maximum of 2 gigabytes of memory. Well, we can do that by setting those limits on the Trevor project with the LXC CLI. So if we try to edit, watch what happens here. If we do LXC project set Trevor limits.cpu2, we're going to get an error. And that's because the instance, the virtual machine instance U01, doesn't currently have a CPU configuration. Now, the default is going to be a single virtual CPU, but it's not explicitly declared on that virtual machine. And so therefore, we can't configure the project to have limits until the virtual machines that are members of the project have that setting as well. So if we do an LXC profile edit on the default profile here, we can go down to the default profile config section and say limits.cpu and set that to 2. And so now the virtual machine should have 2 virtual CPUs on it. So let's go ahead and try to set the limits at the project level again, and you can see that it works perfectly fine right here. Let's try the same thing for memory. So we'll say limits.memory, and we'll say 2 gigabytes of memory. And once again, because we don't have an explicit configuration on the virtual machine, we need to first set that on the profile or the individual VM, and then we can go back to the project and customize it. So we'll do LXC profile default, or actually set, and then we'll say default, and then limits.memory is 2 gigabytes. And as you can see, we get an error here just saying that we can't change the memory size on the VM while it's running, but it has technically updated the config. So what we'll do is say LXC restart on U01, and that should change it to 2 gigabytes. So now that we've changed the profile configuration for our virtual machine to have 2 virtual CPUs and 2 gigabytes of memory, we should be able to set the limits at the project level. All right, so now we've got our project configured for 2 virtual CPUs total and 2 gigabytes of memory total. If we do an LXC Project show Trevor, you can see that those settings are in place again at the project level, not the profile level, right up here. So we have 1 virtual machine, and because we configured our default profile to use 2 virtual CPUs and 2 gigabytes of memory, we should not have any system resources left over to provision additional virtual machines, right? So what would happen if we tried to run a launch command again? So we'll do LXC launch VM, and we'll do U02 as a unique name. And as you can see, we have reached the maximum aggregate value for memory because U01 has all 2 gigabytes of memory allocated to it. So there's no free memory in this particular project for a new virtual machine to be spun up. So one thing that we could do would be to actually modify the configuration or override the configuration of that 1 virtual machine to use only 1 gigabyte of memory and only 1 CPU core, and that'll free up resources just again within that project scope so that we can create another virtual machine. So let's do an LXC config edit on U01. And we'll go down here and say under config, again, we're configuring the specific U01 virtual machine, not the default profile. We'll say limits.cpu1, limits.memory, 1 gigabyte exactly. And again, we're probably going to get an error because it's not, it's currently running and we can't bump down the size. So let's do an LXC restart on U01 just to make sure that everything gets reconfigured. And now if we try to launch a second virtual machine, we're going to get an error again because we bumped our U01 down to 1 gigabyte, but our default profile specifies 2 gigabytes. So if we try to launch a new VM, it's going to try to take that default profile setting for 2 gigabytes and 2 CPU cores. So what we need to do is override the default profile and say, I want 1 CPU and config limits.memory equals 1 gigabyte. And as you can see, now that we are staying under that project limit, it does allow us to launch a second virtual machine. Awesome. So that's how things work from a limits perspective. You can constrain CPU, memory, other types of resources at the project scope. You can also limit a specific number of virtual machines. So if you want to, you can say limits.virtualmachines, and you can specify the maximum number of VMs that can actually be launched. So if we were to try to edit that, let's do LXC project set on Trevor. We'll set max virtual machines to 2. So even if we tried to launch a third virtual machine, we would get an error because we don't have enough system resources. But let's go down. Let's actually do this. Let's actually change the limit to 1 right here. But we, of course, need to delete one of them first. So we'll do a delete on the second one. And then we'll go ahead and change the limit down to 1. And then we'll try to launch that second one again with those limits. And as you can see, we get a different error this time. It says reached maximum number of instances of type virtual machine in Project Trevor. So there's various limits that you can apply. It can either be based on the number of virtual machines, the number of containers, the CPUs, the aggregate amount of memory assigned to the VMs, whatever you want to do. That's how the limits work for the projects. All right, so now that we've talked about limits and we also talked about features and inheritance of features, let's talk finally about the access control component of it. At the moment, we've only been accessing the LXD daemon locally from the LXD server, right? So what if I wanted to use my local system here, which is running Windows 11? What if I want to use LXC locally to access the project called Trevor on the LXD server? Well, what we can do is come in here and on our server and say LXC config, and then we'll go into the trust configuration here. And let me list here, because I think I already have one. Let's do a trust remove on that fingerprint really quick, just so that I clear out any trusts. So this is normally what you would see by default. So what we can do is add a new trusted client. But when we run this command, we actually have the -- projects here, which is a list of the projects that we want to restrict the user to. And then we also have to make sure we do -- restricted, otherwise the restriction will not apply. So let's do LXC config trust add, and we'll specify -- projects. We're only going to specify one project, which is Trevor, and we're going to specify that this user is going to be restricted. So we'll provide the client name, which is Artemis, and we'll copy our join token, or our trust token here, I should say. And over here, we'll do LXC remote list. And I should just have the default remotes. Actually, it looks like I have Pangea configured there. Let me just delete Pangea really quick. Let's see, it says LXC remote delete. Oh, I need to do remove Pangea. And now if we do a list, now I've just got the default remotes. So now I want to re-add the remote with the new trust token that we have. So I'll just do a LXC remote add, Pangea, specify the IP address, then we'll be prompted for the trust token. It'll ask us to confirm the server's fingerprint, and we'll plug in our trust token here. And so now our LXC client is trusted by the LXD server, but only for that Trevor project, right? So now if I try to switch my remote, I'll say LXC remote switch to Pangea. So now any LXC commands that I run are going to operate against the Pangea remote right here, which is of type LXD. It's an LXD server, not a simple streams image server, of course. So if I do an LXC list, we're going to see the Trevor project virtual machines here. And as you can see, we've got U01. But what if I try to do an LXC list on, let's say, project default? Well, I get a not authorized because I don't have access to the default project. I only have access to the resources inside of the Trevor project. So can I stop a virtual machine in the Trevor project? Can I do LXC stop U01? Well, yeah, because I have access to manage the resources in the Trevor project. What if I do LXC image list? Can I see the images in the Trevor project on that server? Yes, I can. Can I copy an image from an image server down to here? We'll do LXC image copy. We'll specify -- VM. We'll grab images Alpine 3.18 and copy that to Pangea remote. So let's see if that works okay. So that should go to the primary image server, grab the Alpine Linux operating system image, and then copy it down to our current Trevor project. And as you can see, this is working perfectly fine as well. If I do an image list again, you can see that we've now added Alpine 3.18 to our list of images. So I, as a restricted user, can still do everything that I need to inside of this project, but with the limits that the administrators have put in place for the aggregate CPUs, the aggregate number of virtual machines, aggregate amount of memory allocation to virtual machines and containers, but I can still do the work that I need to. So anyways, projects are pretty simple to understand, but they're a very powerful and very configurable entity within LXD. So hopefully this video has helped you to understand a little bit more about how projects work and why you might want to use them on a LXD standalone host or on a LXD cluster. Actually, speaking of clustering, there is a setting 4 clusters over here in the restrictions where you can actually limit targeting of a particular cluster node. So if you don't want somebody to be able to schedule a specific virtual machine on a specific node or member within a LXD cluster, you can actually enable that feature to block somebody from doing that at the project level as well. So go through the project configuration reference here and check out all the different settings that you can apply for projects on your LXD server. Thanks again for joining me on this video. If you learned anything new in this video or just enjoyed my presentation, please leave a like. I'm an independent content creator, so your interactions, whether it's liking, commenting, subscribing, or going to the community tab to take quizzes that I periodically post out there would really help me out a lot. Also, feel free to look up my links down in the description for my other social media channels and follow me on Facebook, TikTok, and Twitter, and others as well. Thanks so much, and we'll see you in the next video. Take care.